So yeah, challenges in distributed software development in bioinformatics. George indeed submitted the abstract and participated in creating these slides. George is based in Africa. He's a member of the Kenyan Medical Research Institute, which is part of the Wellcome Trust. And so we're hot on diversity in Ruby. Francesco's here or not? Yeah. Ah, he could have done the talk. But yeah, it's a long list, so.
That's a nice start.
Right, so this slide I presented last year is saying, okay, the project formerly known as BioRuby is now a Biogem project. And there's a few things that struck us when we looked at all the data is that, we have a number of new contributors. We actually don't know who they are. There's virtually no mailing list activity that we noted. BioRuby is almost at 100K downloads, which is really good. 25 packages have more than 10K downloads, 19 packages have more than 10K GitHub stars. And what does this all mean? The intention when we created Biogems is that, as core contributors of the project, we wanted to be hands-off, we wanted to delegate. And we wanted to create a low barrier to entry. And we didn't really want to ask questions about people and what they were doing, right? And code could prove itself, right? If something is good, so people will use it. If it's not good, it'll disappear. It's evolution. So we created the scaffold generator, a scaffold package, which is really a tool which creates, a GitHub repository and a Biogems instance and a testing framework, a structure, so people can just start filling in the blanks and build their tool on that. And it's enough to get started. Yeah, we publish this as a paper. And BioJavaScript is actually doing the same thing. It's really interesting. So they had 90 packages in the last year, coming from 5. They have 11 publications since 2013 for different modules. There's some popular packages. They're coming. They're coming fast. I just like this slide. So how do you measure success? The number of users, maybe through downloads, number of publications, number of GitHub stars, issues, patches, number of messages on BioStar's mailing list, number of contributors. How do you measure success? Really? So we made some graphs. This is a plot, the left plot we have the number of downloads for every package which are unreadable, right? And then and the right plot we remove the outliers. Yeah, so scale it a bit better. So we also have histogram. So these are the GitHub issues ranked by package, by module, and I'm pleased to say that there is at least 4 of my modules there in the top ranks, which really means they're either bugs or requests for more, right? A lot of issues does mean something, I think. We have another plot, which is conversations on the mailing lists between Ruby, BioRuby, and BioPython. Yeah, so since 2004. You can see a spike here in blue in BioPython. I don't know what happened. Any idea, Peter? Yeah, it's around 2009, 2010. Is this what happened with BioPython? Maybe somebody joined the project and left?
The first one.
Yeah, probably. Yeah, it's hundreds of messages, really. Right? And interestingly, Ruby went down, and I don't know what happened. Yeah, and then it sort of converged, and we went happily together, and then it became more like looking like German bonds versus Greek bonds. Yeah, so and now we're at the same level again. It's interesting. Yeah, heading to a 0, by the way. Okay, so we also, I had all these nice plots, so we also had a correlation plot. So on the left one is downloads versus issues. Right, and the other one is stars, GitHub stars versus issues. I don't know if you see any patterns. I think the correlation is quite high actually on both of them, at least 0.5. So the first conclusion slide is the author should not do statistics. In fact, last year Carl Broman was in the room, and he's a professor of statistics, and he would have crucified me for this presentation so far. The author should not present figures, no. But also we can say there's no straightforward metrics that I can tell, that we can measure success. Skip this slide. So one interesting thing is, because we're in biology, we're in bioinformatics, we published a paper early this year on Sambamba. And immediately after the publication, the number of downloads went up, and also the number of issues went up rapidly, right? So people reporting bugs and people reporting feature requests, really. We at least know people are using the software, right? And when your paper gets cited, you can assume it's being used too. So the second conclusion slide, I think, Biogem is actually a success. One interesting fact is we have 40 new packages in the last year, and that compares to 100 in the previous 4 years. That's rapid increase. The Biogem paper got 12 citations last year, and the year before that was 1 citation. We had our first citation the year before that. There's a package for Biogems Tools, which had its own paper, and it's obviously a project that's doing well. And we have 5 new contributors at least, and I don't know who they are. So, no. This slide I didn't use last year. In biology, where do people think software comes from? I believe that many people think that software comes from the sky. Right? I don't have to. I mean, we know where it comes from, but I think it's a real problem. And I talked with a lot of people last year here also at BOSC, and I think bioinformatics is in something of a crisis. And the questions I came up with really are, why are published FOSS projects not maintained? How come, for example, BioPython gets no funding? I mean, all the software developed is happening on the back of other research, pretty much. How come talented developers opt for traditional jobs? I see that. Or leave for industry. I see that a lot. And why are we not educating enough people? There's a new journal that came out last month. It's the Reward Deficiency Syndrome Journal. I think we should publish there. So we actually submitted the paper to Nature Biotechnology together with Phil Bourne, who was the keynote speaker last year. And it got accepted, and it got published this week. And its title is Towards Effective Software Solutions for Big Biology. And the four main conclusions I distilled are that we need to ramp up investment in bioinformatics, and especially software engineering. We need to attract bioinformaticians and offer them attribution and a career path. We're not doing that right now. We need to encourage people to create FOSS, build on the shoulders of other people. And we could create foundations to fund software development rather than trying to do software development on the back of other research all the time. To individuals, I have the following recommendations, and that's to read the Small Tools Manifesto. I don't know if you've seen it. It's at the bottom of the link. To learn new tools and programming languages, really. Yeah, we really get stuck in the language that we learn first. There are many good languages out there, and they're more appropriate for some jobs, especially when you look at high-performance computing. I think it's also important to use digital object identifiers to sign your software releases and to use them, to encourage people to cite them and to mention them with your downloads and references in your CV, right? Because what we need to do is journal publications are one measure in science, to measure how well people are doing as in the career. But I think a good piece of software is at least as valuable as a journal publication, and we should be able to use that as a to build up our careers. And I have a final suggestion. I think I would like to ask LBF to consider creating an award, because we need role models for software engineering, right? And it could be an award, something like this. don't know. I hope it's open access. It's a future winner. Yeah, I'm done.